seated. Dear students, dear relatives and other supporters of the students, dear colleagues, my name is Mark de Berg and I'm a professor at the Faculty of Mathematics and Computer Science, and it's my pleasure to welcome you and all the candidates, of course, for this graduation ceremony. I'm very happy that we can celebrate this event together on our campus. As a department, we're quite proud of the fact that today you, the students, are getting their degree of Masters of Science. It has been a result of hard work and I guess for some of you under difficult circumstances because of the pandemic, but here you are finally being able to celebrate and get your diplomas. You have received, I think, a very strong and nice education with many courses where you learned many things, followed by a challenging master thesis project where you learned even more. So all of these things together have prepared you very well for the next steps in your careers. The Examination Committee for Computer Science and Engineering has assessed the work of the following candidates. Jorg Bekelaar, Milan Hutten, Thijs Joosten, Ying Lu, Joris Peters, Daan Wultgens, Kai Wortel and Varun Kamat. In addition, the Examinations Committee for Embedded Systems has assessed the work of the following candidates: Rok Shepin, Devi Darshini Manikam, Niek van der Dussen, Martijn Tuinstra and Rick van de Wetering. And the Examinations Committee for IST has assessed the work of the following candidate: Luc Godschalk. Dear candidates, Masters of Science, you have all passed your examinations, and therefore you will now be conferred your degrees for the Master Computer Science and Engineering, or Embedded Systems, or Information Security and Technology. This degree entitles you to the title Master of Science, and if you want also the Dutch title Ingenieur. Our program highly values personal contact between lecturers and students, and so at the part of your last part of your studies, you will now actually get a personal speech from your supervisor of your graduation project. So now we begin with that part of the ceremony. So yeah, I will show, let's see if this works. Should I? Let's see, is it? Okay, so yeah, now you will see the slide of your work coming up one by one, and when you see the slide, please come forward and your supervisor will hand over the diploma and present your speech. So I invite the first candidate to come forward.
Hi, Jorg. Congratulations on your success and on this achievement. In your master project, you addressed a very relevant problem in the healthcare system in the Netherlands. Your project focused on being able to measure the amount of work that nurses perform during their shift, but you also went forward and you also worked on predicting which kind of work is expected on the next day for the nurses to better plan their work. Your work opened many doors. Well, for us, especially Yolanda, your company supervisor, and us, and me, to continue working on this project that we call together Happy Nurses. And it opened many doors for us to move forward and work on making the nurses happier. I think that the whole project was a very nice experience for you. First, because you were able to approach and work with many different people, starting with me, data scientists from the hospital, but also directly with the nurses. But also because you had a paper that you published, which gave you the opportunity to join me and the rest of the research team in a trip to Italy. And, well, I think I could say that we had a very nice time there. But besides this one time that we had this very nice time, I can also say that it was very pleasant to be your supervisor, to work with you in this project. We had many nice discussions, of course, with Yolanda with us, but discussions related to the project. But we also got the chance to discuss unrelated things, which also gave us the opportunity to know a bit more of each other. Well, having said that, I am just sad that you are not my PhD student now, but I can only wish you a lot of success. Well, congratulations again.
Thank you very much. It's all about it. Thank you so much. Picture lady is. Oh, okay, fine. All right, I'll do this speech in Dutch because we were asked to prepare the speech in the language that we used to talk to our students. Dus beste Milan, ik denk dat het weinig had gescheeld of ik had je hier niet toegesproken. Het zit namelijk zo. In 2021 volgde je mijn vak Process Algebra. En bij dat vak werken studenten aan een drietal huiswerkopdrachten. En dat mogen ze in groepjes doen van 2. En nu had jij de pech dat degene met wie jij samenwerkte er halverwege de brui aangaf. Die was mij overigens toen al opgevallen als een van de weinige studenten die zijn camera aanzette tijdens de online hoorcolleges. Wat voor mij heel prettig was, want dan heb je tenminste het gevoel dat je tegen publiek praat in plaats van tegen je laptopscherm. Nu goed, je partner had dus de brui eraan gegeven en toen hadden wij gesprek, want jij zag het eigenlijk zelf ook niet meer zo zitten. Volgens mij stond je op het punt om te stoppen met Process Algebra. Dus ik heb toen even op jou moeten inpraten om je ervan te overtuigen dat het toch goed was om het vak af te maken. Gelukkig kon ik je overhalen, heb je het vak met een mooi cijfer gehaald. En een paar dagen later nam je dus vervolgens ook contact met mij op voor een afstudeerproject. Ik denk dat als jij niet door was gegaan met Process Algebra, dat je ook niet bij mij was komen afstuderen. Dus ik heb daar een goede actie verricht, denk ik. Jouw afstudeeropdracht ging over Divergence Preserving Branching by Similarity. Nou ga ik niet dat plaatje daar uitleggen, dat is het gaat een beetje te ver hier, maar misschien wat achtergrond. Dit is een gedragsequivalentie die een belangrijke rol speelt bij de formele verificatie van systemen. Met name gebruiken wij die equivalentie in de door ons ontwikkelde toolset, bijvoorbeeld om modellen van systemen kleiner te maken zonder dat eigenschappen verloren gaan. Daar heb jij je verder niet zo erg mee bezig gehouden met deze toepassing. Wat jij hebt gedaan is vooral je gericht op een axiomatisering, een axiomatische karakterisering van deze equivalentie. En dat is met name bij deze equivalentie heel nuttig, want hij is nogal ingewikkeld. Nou ja, dat plaatje laat eigenlijk wel zien dat het best wel een ingewikkelde notie is. En die axioma's die geven een mooi inzicht in wat er nou eigenlijk aan elkaar gelijk is en wat niet. Dus dat was eigenlijk jouw voornaamste bijdrage ook. Bovendien heb je een sluitend wiskundig bewijs gegeven dat die axiomatisering die je gaf ook inderdaad precies deze notie karakteriseerde, een zogenaamd compleetheidsbewijs. Je hebt een gedegen stuk theoretisch werk afgeleverd en je afstudeerproject bovendien ook heel zelfstandig uitgevoerd. Onze begeleidingsafspraken op maandag verliepen ongeveer zo. Je kwam binnen, ging zitten, begon meteen te praten over je vorderingen. Daarbij scrollden er dan in hoog tempo allerlei bewijzen over het scherm. Dus ik zat een beetje te knipperen met mijn ogen dan. Het ging veel sneller dan ik ooit kon volgen. Maar ik dacht, nou ja, geen probleem. Hij is lekker bezig. Het komt vast goed en ik lees het later nog wel eens een keer. En zo is het ongeveer ook gegaan. En als ik het dan teruglas, dan was het inderdaad ook allemaal goed. Dus dat heb je heel goed gedaan. Het mooie was, dan was Milan klaar. Dit is even voor het publiek. Dan was Milan klaar en dan stond hij op en hij zei... Oh ja, heb je eigenlijk nog wat leuks gedaan dit weekend? Dus dat was ongeveer hoe zo'n begeleidingsafspraak verliep. Milan, van harte gefeliciteerd met het behalen van je diploma. Je hebt het zeer verdiend. Uitstekend werk afgeleverd. En ik wens je het allerbeste.
Okay, I will start in English and last part in Dutch. Thijs has been working on a technique from artificial intelligence called Monte Carlo tree search, and he has been applying that to the game of drafts. In Dutch, that's dammen. And in the last decade, there have been some spectacular results regarding computers playing board games. And one of the biggest breakthroughs was a program called AlphaGo that was developed by people from Google that was able to beat the human grandmasters based on this technique, Monte Carlo tree search. And this technique has also been applied in the game of chess successfully. It can easily beat the world champion right now. But in the game of drafts, the results have been very poor so far. And Thijs has been investigating why it is that this technique doesn't work well and see if he can improve on it. And now, based on the work from Thijs, we can say with a high degree of certainty that this is caused by so-called traps in the game. In Dutch, we call it slagzetten. So what is a trap? That is a sequence of moves where you give away a number of pieces, and then in the end, you capture multiple pieces back in order to gain an advantage. And Thijs has demonstrated in many different ways that M&CS is very vulnerable for these traps. And these traps occur very frequently in the games of drafts. And so this is a real problem, and it even seems to be an intrinsic problem of the method. Now, Thijs has also tried to solve this problem by modifying Monte Carlo tree search, and he partially succeeded in that. Namely, he managed to adjust it such that M&CS is better able to find traps, but on the other hand, it was at the cost of the normal gameplay, so overall it didn't improve the playing strength, unfortunately. So we are still at the level that M&CS is not able to beat the world champion drafts. So let me now switch to Dutch to say a few personal words. Thijs, ik heb jou leren kennen als iemand die heel betrokken is. Je hebt een heel opgeruimd karakter, dus dat maakt het heel prettig om met jou samen te werken. Ik heb ook gemerkt, je bent heel veelzijdig. Je hebt hiernaast ook nog een heel andere studie gedaan, ik geloof iets met psychologie. En je bent ook heel praktisch, heel handig. Je had op een gegeven moment zelf een dambord gemaakt met behulp van een lasersnijder. Dat was echt prachtig. Verder, ja, wat betreft jouw sterke en zwakke punten. Ik heb gemerkt dat daar wat aankomt op de hele technische details, met name met programmeren, en dat je soms een beetje moeite had. Maar waar ik jou heel sterk in vond, is gewoon je ideeën en je inzicht in de materie. Dus ik kon altijd prima met jou discussiëren over de materie. En wat dat betreft heb ik alle vertrouwen in dat je daar in de toekomst ook je voordeel mee kunt doen. Ja, tot slot, ik wens je verder succes in je loopbaan. En ja, ook nog gefeliciteerd met je diploma.
samenwerking met u ook heel graag.
Oké, dank je.
Dear Ying, it's a great pleasure for me to stand here to be able to hand over your diploma. You contacted me already some time back in November 2021 because you wanted to do your master thesis with me. And I was actually quite happy because I sort of inquired about your grades and I found out that you're a strong student, very nice grades. You had also served as a student assistant in some of our courses. And you wanted to do a more theoretical project, which I'm always very happy to supervise. So I was really happy that you wanted to do your thesis with me. And we decided to work on a very challenging problem, which is somehow illustrated on the picture you see on the screen. So it's a problem on sensor networks. So this network you see, ignore sort of the honeycomb structure behind it. You see all these nodes that are connected to each other. Those are supposed to be sensors that can communicate with each other when the distance between them is small enough. Now, what is sometimes useful is if you have sort of a backbone of this network, which is a sort of smaller part of the network, which is also connected. And from that smaller part, you can sort of reach the rest, which is not in this backbone. And a well-known problem is to try to compute such a smallest backbone. And in technical terms, that's called a connected dominating set. Now, this is a very hard problem, so there are no good algorithms that compute an optimal solution. So you want to have something where you can show that it's almost optimal. And what made it even more difficult in your case is that here, you have to compute it sort of locally. So the nodes themselves have to decide whether they're part of the backbone without knowing the entire network. So there's a lot of work on that. And the first thing actually you found out that one of the papers that gave the best results so far is wrong. And you improved or corrected, I should say, the analysis and gave a correct analysis of that algorithm. So that was already quite a nice result. Then you also looked at another algorithm from the from the literature, and you that was not wrong, but you managed to improve it. So that was also very nice. And then as a third contribution, you looked at the scenario where there's sort of things in between the sensors that may obstruct communication. So it's not just a distance between them, but if there's some kind of building in between or something, then they cannot communicate. And you also had some very nice results there. So I think in total, you can be very proud of your results. The results were very nice, but still it was not always an easy process for you, the whole thesis project. So in the summer last year, you decided to go back to China for a couple of months. And then you came back to be able to work with full energy on the project again. And I was very happy to see that you were really back on top of things and managed to finish it then with a very nice thesis. I was also very happy with the nice cookies you brought from China, which were very nice. So I think you can be proud of your results. You can also be proud of the way you handled when things were not going so well, that you sought help, you took control of the situation, and you came out strong. So also from that perspective, very well done. So finally, let me congratulate you again, and I wish you all the best in your future career. And I think with your strength, you should definitely be able to do some very nice work in the future as well.
So I will do this speech in Dutch. So although at our weekly meetings we actually spoke English because your supervisor at ING was non-Dutch, but I think because we're both Dutch, it makes sense to do this speech in Dutch. Geachte ingenieur Peters, beste Joris, van harte gefeliciteerd. Ik heb je samen met Michel Chaudron van de Software Engineering Technology Groep mogen begeleiden bij je afstuderen. En dat was een groot genoegen. Je wilde graag bij een bedrijf afstuderen en na enkele interviewrondes bij ING was je goed genoeg bevonden om bij hen aan de slag te gaan en daar je afstuderen uit te voeren. Vanuit ING was eerst Luna je begeleider en na ons intakegesprek waren we eigenlijk alle vier heel erg enthousiast en hadden we er alle vertrouwen in dat jij de toch wel uitdagende en open opdracht toch tot een succesvol einde kon gaan brengen. We wisten toen alleen nog niet wat voor apen en beren we tegen zouden komen op de weg. Goed, je werk was een combinatie van software engineering en visualisatie. Bij ING hebben ze wat betreft de software een microservice architectuur. Het is een soort van hippe term waarbij je je software opdeelt in allerlei kleine stukjes. En elk van die kleine stukjes heeft dan een specialistische taak. Het idee is dat je dan grotere taken kan doen door die stukjes met elkaar te laten praten. Het probleem daarbij is dat op een gegeven moment niemand meer echt een overzicht heeft van al die stukjes en hoe ze met elkaar communiceren en of dat wel optimaal gebeurt of niet. Aan Joris was de taak om aan de hand van die communicatie de overal architectuur in kaart te gaan brengen en dat te visualiseren. Je hebt je op dat probleem gestort. Daaruit is een hele mooie oplossing gekomen, gebruikmakend van metrieken en verschillende visualisatietechnieken. Het is echt een combinatie tussen software engineering en visualisatie. En die oplossing bleek voor ING ook heel erg nuttig, want dat is zowel nuttig voor de software ingenieurs als ook voor de software architecten. Dus uiteindelijk heb je een hele mooie oplossing gemaakt in de vorm van een prototype. Echter, de weg naar die oplossing was alles behalve mooi te noemen. Volledig buiten jouw macht en schuld om. Dus ik heb echt groot respect hoe je met de hele situatie bent omgegaan. Wat is er gebeurd? Vlak na je start vertelde je begeleider dat ze intern een andere functie ging bekleden en dat iemand anders de begeleiding over zou nemen. Deze begeleider was echter nog een beetje onervaren en ik had het idee dat het voor jullie beiden vaak een soort zoektocht was naar het vinden van de juiste personen en het vinden van de data. Tot overmaat van ramp werd, zonder dat iemand werd geïnformeerd, 3 maanden voor het einde je contract beëindigd. En het bleek uitzonderlijk moeilijk en uiteindelijk onmogelijk om dit weer te repareren. Hierdoor kon je niet meer bij de data, kon je niet meer bij je scripts, kon je niet meer bij je geprogrammeerde werk. En werd je eigenlijk volledig afhankelijk van je begeleider om alles tot een goed einde te brengen. Gelukkig heb je supergoede eigenschappen, zoals altijd positief blijven en je hebt ook een goede dosis doorzettingsvermogen. Waardoor je het uiteindelijk allemaal uitstekend is gelukt. Je was heel erg zelfstandig, je kan uitstekend literatuur vinden en lezen. Je programmeert goed en ook algoritmen toepassen, dat was allemaal geen probleem. Dus Joris, ik wens je heel veel succes in je toekomstige loopbaan, maar ik ben ervan overtuigd dat dat geen probleem gaat zijn. Nogmaals, van harte gefeliciteerd.
I will give my speech in Dutch, as we always communicated in Dutch. Beste Daan, hartelijk gefeliciteerd met het behalen van je diploma. In 2021 had je je ingeschreven voor het SET-seminar, ter voorbereiding voor je afstuderen. Ik was blij toen je voor dat vak koos voor een opdracht die ik kort daarvoor bedacht had, omdat die opdracht direct aansloot bij mijn onderzoek van dat moment. Toen je de voorstudie daarvoor heel goed had afgerond, werd het nog beter, omdat je ook besloot op dit onderwerp af te willen studeren. Je hebt onderzocht hoe een nieuw ontwerp voor een hashtable in de praktijk presteert. Een hashtable is een datastructuur waarin gegevens heel snel kunnen worden opgeslagen en teruggevonden. Al een aantal jaren wordt er onderzoek gedaan naar het gebruik van zulke hashtables door grafische processoren. Dat zijn processoren met heel veel rekenkracht, maar weinig opslagruimte. Ze zijn vooral bekend vanwege hun visuele prestaties bij het spelen van videogames. Ingaan op de technische uitdagingen is eigenlijk niet te doen in een korte speech als deze. Maar de kern van de zaak is dat deze grafische processoren veel rekenkracht hebben, maar ook veel technische beperkingen, waardoor je zoiets als een hashtable van de grond af opnieuw moet ontwerpen. Ik had een idee voor een nieuw ontwerp, waarbij de gegevens compact kunnen worden opgeslagen, wat ervoor zou zorgen dat de beperkte opslagruimte van een grafische processor efficiënter kan worden gebruikt. Maar ik had geen idee hoe deze nieuwe hashtable het in de praktijk zou doen. Werkt hij snel? Kan hij inderdaad meer gegevens opslaan? Een grote uitdaging bij deze opdracht was hoe we dit moesten meten. Het is gebruikelijk om te vergelijken met bestaande state-of-the-art, maar een dergelijke hashtable bestond er nog niet voor grafische processoren. Wel was er een hashtable-ontwerp voor multicore processoren, de hoofdprocessoren van computers, maar die omzetten naar een ontwerp voor grafische processoren zou niet eenvoudig zijn. Ik wist uit ervaring dat het implementeren van die bestaande hashtable voor grafische processoren heel lastig zou zijn, waarbij een fout al heel snel geïntroduceerd kon worden. Tot mijn verbazing ging je aan de slag en had je eigenlijk al heel snel een implementatie voor grafische processoren klaar. En dat kenmerkte eigenlijk je hele project. Ik legde je een uitdaging voor en jij sloeg je er met gemak door, zo leek het althans. Bovendien legde je zelf de lat nog hoger. Vanaf het begin van het project wilde je het vergroten of resizen van hashtables onderzoeken, een aspect waar je zelf mee aankwam. Dat geeft aan hoe serieus je met het onderwerp bezig was en dat het project goed liep. Wat dat betreft heb ik niet zoveel komische anekdotes voor vandaag, geen gemiste afspraken of misverstanden. Je hebt heel professioneel dit project aangepakt. Al snel besefte ik me dat tijdens het project dat we de scope konden vergroten om ook multicore processor implementaties te beschouwen. En hiervoor nodigde ik Alfons Laarman uit, universitair docent aan de Universiteit Leiden. Met zijn expertise konden we het project breder aanpakken. En dat project bleef op dezelfde voet heel goed verlopen. Misschien werd je af en toe gek van de eisen die we stelden. Kun je dit aspect nog eens bekijken? Kun je nog experimenten uitvoeren om dat aspect te belichten? Kun je nog een ander type hashtable betrekken in de vergelijkingen enzovoort? Maar je sloeg je daar heel goed doorheen. En heel fijn natuurlijk, het nieuwe ontwerp bleek inderdaad de state-of-the-art te overtreffen. Wat tekenend is voor je professionele houding, is dat je na je afstuderen bereid was om je in te zetten voor een submissie naar een conferentie. We hadden eerder al herkend dat jouw resultaten publiceerbaar waren. Enkele maanden na het afronden van je project kwam de submissiedeadline van de Europar-conferentie in zicht. Natuurlijk hadden we daarvoor weer een nieuw wensenlijstje en jij ging daar weer druk mee aan de slag. De deadline voor die conferentie werd uiteindelijk gehaald. Het was een hectische, intense samenwerking, omdat er weinig tijd was, maar die liep toch verrassend gesmeerd. Nu is het afwachten op de uitslag van die submissie, maar ook als het werk afgewezen wordt, weet ik zeker dat het bij een andere conferentie aangenomen gaat worden. Ik geloof dat je een goede onderzoeker zou zijn, maar de toekomst zie jij in het bedrijfsleven. Ik weet niet of je inmiddels al de baan hebt gevonden waar je de volgende uitdagingen ziet liggen. Waar je uiteindelijk ook gaat werken, ik weet zeker dat ze blij zullen worden met zo'n goede professionele collega. Nogmaals gefeliciteerd en veel succes in de toekomst.
I will do this speech in English, but mostly because I don't know Dutch. Kai, congratulations. It was very nice working with you. And Kai worked with us in a database group. How are we doing with time? Have more time? Can do a mini lecture what we do in database group. I'm just joking. So we like graphs in the database group, or specifically graph databases. Think social networks, transportation networks, biological networks, and so on. And one of the difficulties actually in the graph databases, unlike the relational databases that you typically have, which look like tables, right? So think of spreadsheets, Excel spreadsheets, is the evaluation of complex analytical queries, which involves connections between entities, right? That's why you would use a graph database. And one of the things when you start doing this complex analytics is that you are quickly starting to explore very large prohibitive search spaces. And that essentially just, you're not able to run complex analytical tasks afterward. Now what Kai did, he explored recent advances in a database technology, specifically related to the factorization of intermediate results. So essentially, instead of representing our intermediate results while we're doing our search and storing things that we found so far as a table, we'll just factorize and instead store the intermediate results as a graph. And that could often be, often will take much less space because of that. And what essentially it allows you to do, it's really a breakthrough in the graph database technology because it allows you to run very complex analytical queries that you were not able to run before because you just ran out of memory, and that's it. So thanks to Kai, who independently researched this topic and implemented his results in our database, our own database that we have in a database group, OneGraph, these things are now possible. And that's an excellent result. We're working on a submission for a top-tier conference, and I think we have a good chance of being accepted. But this is not all. So Kai, in addition to his graduation project, he also worked with us on multiple other things. And so I think we did Capital Selector together, we did an internship together, we did a seminar together. So everything that you could do with the research group, Kai did with us. So thanks for that. And another thing is also related, what he was working on, is on a theory of worst case complexity. So recently, there has been advances in analyzing the complexity of querying the database. And specifically, what people found out is that it is often the algorithms in use today, so the join algorithms, for example, are actually not worst case optimal. So that means they do more work which is necessary when compared to the analytical, theoretical analysis. And towards that, actually several types of algorithms have been proposed which are worst case optimal, so you're not wasting work. And you can prove that also. But there are several disadvantages to these approaches because you need special data structures, you need special indexes, and then this is actually, you have to pay, right? There is no free lunch. But what Kai did, he also worked on implementation and research and development of several kinds of different data structures that at least allow you to ease the pain of creating and maintaining those data structures. You still pay, but you have to pay much less, right? So you can try to have your cake also. So Kai, thanks so much for this, I think, very productive year, at least, together. We really learned from you a lot, and I hope you learned from us quite a bit. And yeah, best of luck with your future endeavors. Thanks again. All right, good stuff, man. We'll talk later. Next up, Varun. Varun, come here. Oh, wait a second. I'm sorry. Varun, congratulations. You see, when there's more than one, always something happens. Now, Varun, I am not your supervisor. I hope you know me. You've seen me probably somewhere around in the floor in our department. And actually, Yulong, who is one of the researchers in our cluster, was supervising you. And unfortunately, he cannot be here today, but he gave me this opportunity to deliver his speech for him. Again, the speech is in English, so I'm just going to read this. Dear Varun, congratulations with the successful completion of your master's studies. You chose to do your graduation project with Signify, a company we all know. They offered you an exciting and challenging research topic, clustering a multi-class dataset using deep learning approaches. You were well prepared to do this project. You obtained earlier experience working at Signify, so you're familiar with them, where you did an internship on building recommendation tools using machine learning and AI to reduce the business cost within the department. You also gained relevant research skills during your graduation seminar. Supply chain is important to Signify as a company because it ensures the company can efficiently and effectively deliver the products and services to their customers. Supply chain management helps Signify streamline their processes and ensure they can meet the customer demand. By managing the supply chain, Signify can ensure that they have the right products in the right place and the right time, and also at the right price. As a business requirement, Signify's component team would like to minimize the risk when alternative components should be selected. You mapped this problem into a clustering task and proposed a novel approach that uses deep neural networks to simultaneously learn feature representations and cluster assignments. The effectiveness of the method has been validated on the real-world datasets at Signify. During the project, you demonstrated a high level of independence. Throughout the project, you proactively came up with different ideas and pursued them, achieving much more than what was asked. You were always eager to take feedback seriously and seek for ways to improve your work further. It was a rewarding experience to supervise you. I was happy to hear that you received and accepted an offer as a data scientist at DLL, focusing on creating AI models to help optimize and enhance the loan approvals. Congratulations again on completing your project, and I wish you the very best in your future endeavors. Thanks for it again.
Het lijkt er wel zo op dat helemaal die beamer uitgevallen is. Wow. Wow. Nou. Congratulations.
Maar dan moeten we nog de goede vinden.
Ja, het stekkertje was er gewoon.
Oké.
Contact meer.
Is er een volstrekt ander beeld dan daar?
Ja, ik zie hier iets. Het lijkt een hele andere presentatie.
Echt waar?
Ja, dus we zijn ondertussen een stuk verder. Maar...
Oh.
Even kijken hoor. Oh, wacht, want dit is ook de verkeerde.
Ik denk dat jij het beter weet dan ik.
Deze is het.
Oh, kijk.
Okay, excellent. It seems that we're back in business.
Ja.
This one.
Nee, de
Vorige.
met die mooie verlichtingsdingen. Right. I almost believed that we were at the wrong meeting, but I recognized Rock Sabin was here today. So Rock, first of all, congratulations with very nice work. Congratulations with the results. But this is the moment. This piece of work. Rock, now it's the moment to explain what you have been doing. And I would like to start that by asking you in the audience, is there possibly something that you miss here in this hall? And that could be, let's say, the connection to the outside world. Imagine that you would have a hole in the roof and then you could see the lights coming in there. Would that make you feel more natural, more comfortable? Well, Signify, the company that was just mentioned previously, used to be called Philips Lighting, and we tend to sell artificial light as well. And one of the new products are these ceiling lights, but they are artificial. And the simple question to you was, dear Rock, what is a cloud? And put it in a tiny little box. Basically, we wanted to have an embedded system that could, let's say, mimic as if there was sun. You prefer to live in London, but here in Holland we have a lot of rain and a lot of clouds. So can we mimic the effect of clouds and the sun being somewhere also in the sky? And that sounds very simple. I even presented it like a tiny kindergarten kid could do it. What is a cloud? And they draw it. But understanding the physics of how light scatters, what makes the sky blue and how do these blue colors change over the day? What are the colors of the clouds exactly, such that, let's say, any one of you could not see the difference between an artificial hole in this room or one of these products? How would people react to a simulation of that? Maybe that's more important than whether it's physically exactly correct. And all these things then need to lead you to put it in a tiny processor that can do this. Make a small algorithm out of that, make an architecture that makes it work. Do we need the position of the sun accurately? And all these kind of things. And that was how you have been approaching this problem. So very broad scope, certainly with a lot of embedded systems in it, but also human perception, a lot of physics, the engineering parts to it. And I admire how you did that. And you had also to work with a lot of stakeholders. The company who just likes to improve that product, driving you to getting nice results there. Me as a scientific advisor who would like to see some breakthroughs in how you could efficiently model these clouds in an efficient way. The statistics of them, how fast do they go, how large are they different in London than here in the Netherlands, and all these kind of things. Tanir as Lebi looked to it from the program. Is it really an embedded systems problem? How do you get it in a tiny box, basically, so to say? Samantha Peters was doing things on human perception. Leonard IJzerboot was, in the end, responsible for making sure that what you were inventing could end up in that small embedded processor. And then we had you, who wanted to have this diploma. You got that. But you also had huge expectations, maybe your second you that wanted all the best in all this possible. And it was, of course, a pleasure to advise you, because my approach would then be, if you want to have something done, ask a busy man. That's a Chinese saying that I adopted there. You were very busy and you tried to do all that. But maybe the best learning for that is embedded systems have constraints. Humans, all of the humans, also have constraints. In memory, in processing power, in R&D time, in hours they can be up and running, and so on. And I think that has been a very, hopefully, rewarding activity for you to go through and to learn from all of that. So with all these observations, maybe I like to end with that, maybe a last message that I would like to give you, although I do think there are a number of interesting things that would be certainly publishable, depending on whether the company first wants to make products out of it or not. But make your supervising team co-responsible for making your life easier, because it was a wonderful piece of work. But we also saw how that strained you in some parts of the activity. So I'm amazed by how broad that work was. On behalf of TU Eindhoven, congratulations with a well-deserved diploma. And if I may so also on behalf of Signify, thank you very much for a very interesting contribution to everything. And basically, that brings me to also another way of celebrating the fun. Congratulations.
Okay, so let me see. First of all, congratulations, Devi, for this wonderful achievement and this fantastic moment of your life. So you have worked in the company called iTech, which is a small company which makes machines that deals with wafers. These machines are very similar to what we see from ASMLs. However, functionality-wise, they are different. And the thing is that these machines, their productivity is extremely important for the company and the industry itself. That means they need to produce more and more chips. And as you know all, that the car industry and all the industries requires more and more chips, and productivity of these machines are very important. And that's the reason the company, or many such companies, they are really interested in making the machines operate as fast as possible, which basically makes it very time critical. The other thing is that these machines basically deal with small dies or wafers, and those are very tiny, you can even not see in the bare eyes, and that makes it very hard, and basically the control that requires to handle those machines need to be extremely accurate. Now, that's the source of many challenges that Devi's project deals with in designing such machines. And one of the challenges is that since these machines need to produce more and more chips, they need to handle different size of dies. Now, every time the die size changes, the company has to retune the algorithm. And that was a problem for them because they have to spend a lot of money in retuning it. And that's the reason they wanted to use, or they want to use AI or DNN to handle different size of chips with the same algorithm. And that's the contribution where Devi's work comes into play. And basically, DNNs are good because they can handle many of the chip sizes, but the difficulty is that they are very time consuming. Since these machines need to operate at a very fast rate, improving the performance of the algorithm is extremely important to adopt these algorithms in the real machines. And when Devi started, it was not clear to the company and myself that what are the specific requirements that these algorithms have to meet. So Devi's project actually was the basis to explore what are the possibilities that these algorithms can explore, what are the strict requirements those algorithms need to meet so that they can be adapted in the real machine and really can improve the performance of those machines. And as you can see in these graphs, Devi has explored many possibilities in terms of hardware, the models and the algorithms and the middleware like inference engines. So that's the contribution Devi has. And at the end, she came up with a set of guidelines which can be used by the company. Now, good news is that those guidelines are currently being followed, and not only iTech, also another company called Six Technologies, which also are involved in building functionalities for these machines, are using them. So basically, the algorithm or the guidelines that you provided, that really helps these companies to make the future machines, which we are going to again discuss later because you are also planning to write a paper on this. And that's the next part. So in the process, actually, as you can see, I mean, there are many things involved. the company has strict requirements, and Devi has limited time, and there was COVID breakdown, and then the company has very specific hardware that they want to use, and those hardwares were not available during the COVID lockdown. So it was a very challenging situation. And in the whole process, Devi did very well in terms of keeping calm and working hard and listening to all others. And basically, we used to have like long discussions how to deal with this multi-facet challenge that faced. But at the end, it worked out. So she did a significant amount of work, and that is currently being used by the company. And we had a very small team with my PhD student Vibhor Jain, and the company supervisor Sajid Mohammed. And we used to discuss a lot of interesting things during those meetings. And one of the things that I would like to mention is Devi's motivation for pursuing PhD. And all of us actually were quite convinced about your ability to pursue PhD. It's unfortunate that it did not work both at ITech and in my group. But as I said, you are very motivated, and you are still you have started working now, and still you are interested in writing papers and pursuing your research career. And I will support with all my best abilities to pursue your career. And that I would like to wish you all the best for everything that you are looking for in your future. The last gift from TV.
Wel edelgestrenge jonge ingenieur Van der Dussen, beste Niek. Normaal gesproken, als je zoiets omdoet, dan verlaat je de ruimte. Dat doe ik nou niet. Niek weet waarom. Jullie zullen nog even moeten wachten op een uitleg. Niek herinner ik me van het laatste college voordat we met lockdown gingen. Daar zaten 3 hele enthousiaste ex-HBO'ers vooraan elke keer dat ik college gaf. En die vraagden 100 uit en gingen mee in alle discussies. En als je een vraag stelde aan de zaal, dan moest je even ze dimmen om de rest ook nog een kans te geven. 3 daarvan, er waren er 3 vooraan en eentje aan de zijkant. 3 daarvan zijn ook bij mij komen afstuderen. Eentje is er al klaar, eentje staat hier en eentje is er nog bezig. En Niek die kwam met de vraag, ik ben bij ProDrive actief en daar wil ik eigenlijk wel gaan afstuderen. Samen met als begeleider Siert Wieringa. En we zouden wel iets met een netwerkprotocol willen doen. Kan je dat begeleiden? En toen dacht ik, dat heb ik wel gedaan tijdens mijn promotietraject met formele methode en formele verificatie bezig zijn. Maar eigenlijk is het meer het domein van Anton Wijs. Dus die heb ik erbij gevraagd. En toen zijn we samen gaan kijken van wat is nou een goede aanpak. En het bleek uiteindelijk in de tijdsverdeling en heel fijn te werken dat ik samen met Siert jou dagelijks begeleid en dat we af en toe contact hadden met Anton als achterwacht. En we hadden hele leuke gesprekken iedere keer. De voortgangsgesprekken waren altijd interessant, altijd enthousiast, altijd optimistisch. Soms een beetje te optimistisch over hoe voortgang misschien zou gaan. Helemaal aan het begin van het project had je plannen om in juli toch echt naar Tanzania te gaan. Want je vriendin liep daar stage, geloof ik, en daar wilde je toch wel heel graag heen. Ik wilde dat ook heel graag ondersteunen. Ik ben zelf naar Tanzania geweest en dat was een beeldverbredende reis. Dus ik dacht, hoe krijg ik die jongen zover dat het lukt? Maar hij wilde graag afstuderen voor het zover was. En dat lukte net niet helemaal. We hadden hele fijne, vaak filosofische gesprekken over het modelleerwerk. En waar je mee bezig was, was het verifiëren van een protocol voor communicatie. Daar wilde ProDrive mee verder. Die hadden het al gebruikt in een heleboel producten, maar waren zich nu aan het afvragen, kunnen we dit uitrollen over een breder stuk van de organisatie? Kunnen we dit op andere plekken ook gebruiken? En dan moet je gaan kijken, hoe is het ontworpen? Kan dat ontwerp, kunnen we laten zien dat er niks misgaat als je in één keer andere eisen stelt aan het protocol wat je hebt? Dan ga je vragen stellen over wat zijn die eisen dan? En dan blijkt dat modelleren een hele cyclus is en niet een kwestie van, goh, dit zijn de eisen die we hebben, daar maken we een mooi plaatje van, dat rekenen we door en dan geven we er een stempel op. Iedere keer kom je weer nieuwe tegen, iedere keer graaf je dieper. En eigenlijk wat Niek zich afvroeg was, hoe kan ik het modelleren nou zo aanpakken dat het een prettig werkproces wordt in het bedrijf. Niet zozeer de echte uitkomsten van, goh, kunnen we nou hele moeilijke grote modellen doorrekenen, maar hoe kunnen we het nou praktisch inzetten op een manier die misschien ook wel niet te veel moeite kost. En daar hebben we, zijn we goed, leuk mee bezig geweest. En toen moest het opgeschreven worden. En dat was best wel een dingetje. Hoe onderscheid je dan nog wat belangrijk is van wat niet belangrijk is, als je zoveel leuke gesprekken gehad hebt? Dat ging niet zo goed. Uiteindelijk ging dat prima, maar dat kostte even tijd. En de belangrijkste les uiteindelijk, vandaar deze, was dat als je een stuk schrijft in de wetenschap, dan begin je altijd met even uitleggen wat je gaat doen. En toen dat doordrong, toen zei Niek, oh, gewoon een plasketting. Nou ja, vandaar. Dus het is ongebruikelijk om cadeautjes uit te delen, maar dit is nauwelijks een cadeautje. Dus ik denk toch dat die voor jou is. Van harte gefeliciteerd met je diploma. Ook voor je familie. En ik ben heel benieuwd naar de verhalen. Het is uiteindelijk Zuid-Afrika geworden, want je bent nou net 3 dagen terug, 4 dagen terug?
2 weken al.
Oh, toch al? Ja. Nou, ik wil de verhalen heel graag horen.
Dear Martijn, congratulations on your graduation. So first, I would like to introduce when I met Martijn. So I think it's about 2 years ago we met in the Systems on Silicon course. Of course, it was not in person because due to the COVID lockdown, the course was in hybrid mode. Of course, we did not get a chance to interact a lot during that time. And of course, after the course, you also got a good grade in the course, and then you decided to do a master thesis with me. You contacted me saying that I'm interested in the project, Create Your Own FPGA. I don't know if you remember that. Then, of course, we had a discussion. I said, okay, that's a topic we list in Master Marketplace, but still we can discuss about other topics if you're interested to explore open areas. And then we discussed about neuromorphic computing and also other topics such as programmable processors. Of course, then you showed interest in neuromorphic computing. I don't know why. I never asked you why. But of course, it's an interesting topic just for others to understand. Neuromorphic computing is an upcoming computing paradigm in which the computation model emulates the human brain, basically. So in that sense, it also requires understanding of the brain model to be able to optimize the processor that implements the brain model. So, of course, there are some state-of-the-art work which is shown in the figure here, and Martijn started from that. he took time to understand the operation of the processor and also the neuromorphic model, which is not an easy task, given that it's a limited time for a master thesis, and also they don't have background from studies in these kind of areas, which are cross-cutting different disciplines. So he did a good job in understanding, and of course he started, in the beginning it was a bit difficult. You found issues in understanding the architecture. We had some brainstorming. Neither me as well did not understand this because it was new for me as well. So during the process, I also learned a lot from you, which was a good experience. And then, of course, later, the challenge was, of course, this exists in the literature. We wanted to optimize the power consumption because, of course, we can have a new computation model and build a processor, but there's no use if it's not energy efficient or area efficient compared to existing processors. So then of course, you found that the processor is already having certain energy consumption, but then we decided to optimize even further, right? I think you came up with some nice ideas on memory optimization and also pipelining and so on. Implementing those ideas were not so trivial because it's a new architecture and also it's a complex one. But you took your time and you understood it very well, and you proposed new ideas which are actually publication worthy. We never talked about it, but of course we can still talk about it. So then, of course, you achieved a very good result overall. I mean, I think in the end, Martin achieved like 50% lower power consumption compared to the published work in the literature, which is actually a very significant achievement. So overall, it was very nice to work with you. You also have a non-technical skill. You have a musical expertise, which we never talked about much. So he's also multi-talented in that sense. He's also a good engineer. So it was very nice to work with Martin. He is very calm and quiet. If he doesn't understand, he clearly mentioned he doesn't understand, which is a nice property of a student. And then he's capable of handling such a complex design, and that's also what we expect out of our students. So I wish you all the best in your future career, and congratulations once again. Dear Rick, congratulations on your graduation. It was my pleasure to work with you. So similar. We met in the COVID times via Teams and Canvas. We never got opportunity 2 years ago when we met in the course. Of course, later after the course, you came back to do a master project with us, which was a very great thing to do. So of course, when we started the discussion, we talked about first. We talked about one of the smaller building blocks in an LDPC decoder. I'll explain to others what LDPC decoder means. So all of you or some of you might have 5G phones with you currently. So LDPC decoder is a decoding block which inside the 5G standards, which allows you to receive information correctly, and which is one of the crucial blocks. Without that, you won't get higher performance or higher data rate. And it's commercially used in a lot of products these days, and it also will be there in future phones and so on. The algorithm has been proposed in the past, but it was never implemented because when you implement in hardware, it consumes a lot of power and area. So that means your battery will die out soon. So the challenge is, of course, how to design an LDPC for low power consumption and also low area. So since it's a very important block, there are thousands of literature available. That means if you start Googling LDPC decoder, you'll get at least 1,000 papers. So it's very hard to make any difference in this domain because it's very competitive. It's one of the hottest research area. So then we discussed about one of the smaller building blocks in the LDPC decoder called barrel shifting, which is responsible for some shifting operations. But then, of course, he ended up in building a complete LDPC decoder. So that's something very a good result he achieved in the end. So the process was very challenging in the beginning. Of course, Rick did not have any background with LDPC, neither he took any communication courses. So he really went out of the box to learn the background about the decoding algorithms. And also he has hardware design experience from the courses, which helped a lot, but still you have to solve some difficult challenges, like, for instance, making the memory blocks and bringing back to the synthesis flow and so on. So he went really out of the box to solve some of the challenges. So in the end, of course, we proposed very nice ideas for the interleaving and also for the folding factor and so on. And that helped to achieve a very optimal architecture in the end. So overall, the results was very good. And also, again, it's worth publishing. But of course, we talked about your future plans, and he already is one of the co-founder of a startup. So that means that he's already in doing his job, and I think you are doing good there, and I wish your company a successful one. Otherwise, it was very nice to work with you. You were always relaxed. I never found you stressed, which is a very nice characteristics of you. And also, you have a very smart way of dressing. You can also see that. So overall, it was my pleasure to work with you, and you did a good job. And actually, you developed something which my future students can take over and continue and improve further. And I thank you very much for that. Yeah, best of luck for your future career, and congratulations again.
Best leuk. Ja, een tijdje niet gezien. Alweer 3 maanden geleden dat je feitelijk afstudeerde met je presentatie en verdediging. En al die tijd ben je al aan het werk, over later meer. Ja, dus alweer een heel tijdje geleden kwam je bij mij langs met ideeën over je afstuderen. En je had dus bedacht om dat in Nijmegen te gaan doen bij de groep van Bart Jacobs. En dan op het onderwerp gerelateerd aan IRMA, het systeem dat ze daar ontwikkelen. Dat heeft dus te maken met die anonymous credentials die we daar zien. En de IRMA-app, die is misschien wel bekend bij sommigen binnen het publiek. Die heb je soms nodig om te identificeren bij zorginstellingen of ook als je je EPD wil bekijken. Ik heb zelf dat ook geprobeerd destijds, maar ik had nog geen smartphone en nog steeds niet. En toen was ik af, maar voor normale mensen is dit wel toegankelijk. Dus die IRMA-app die zorgt voor anonieme credentials, maar anonieme credentials, dat is zeg maar dat je alles anoniem maakt en eventueel niet meer kunt achterhalen wat er precies gebeurd is. En jouw interesse was ook om te kijken wat je kan doen als er toch nog nader gekeken moet worden als er iets vreemds of vreselijk is gebeurd. En daarvoor had je al eigenlijk in eerdere projecten een eigen kijk en ideeën ontwikkeld. Soms door te kijken naar cryptografische aspecten, soms door te kijken naar juridische aspecten. En dat laatste, dat was niet helemaal een verrassing, want ik zag in mijn e-mail nog ook oude e-mails die je al als student stuurde over de rechtspositie van onze master. Want in die tijd hadden we nog de master die we samen deden met Nijmegen en Eindhoven. Inmiddels is die studierichting eigenlijk zo groot geworden, die studierichting voor information security, zodat we eigenlijk apart af kunnen, dus zonder de samenwerking. Maar destijds was het wat ingewikkelder, omdat het mengvorm was. En ja, dus met al die interesses pakte je dit probleem aan. En het ging op zich voorspoedig, maar ja, uiteindelijk om het concreet te maken en het allemaal op papier te krijgen, dat viel niet mee. En ja, corona kwam er ook nog bij, maar hoezeer dat precies in elkaar stak, dat is misschien niet duidelijk, maar het kwam erop neer dat je een tijdje rust nam, of een tijdje gas terugnam, totdat je op een gegeven moment Nijmegen Bernard van Gastel tegen het lijf liep, daarmee in contact kwam. En dat was zeg maar de redding. Dus daarvoor ook nog hartelijk dank aan Bernard. Want hij heeft ervoor gezorgd dat alles weer op de rails kwam. En toen weer met hernieuwde energie aan het werk begonnen bent. En uiteindelijk met veel aandacht van zijn kant, ook van mijn kant, de TU-kant zeg maar, heb je dus je verslag en je werk af kunnen ronden. Ondertussen, 3 maanden geleden was je al afgestudeerd, maar al daarvoor was je ook al bezig geweest om naar de mogelijke banen te kijken. En dat was ook met succes. Dus je had toen al inmiddels je huidige baan gevonden bij de autoriteit persoonsgegevens. En dat is ook precies iets wat denk ik heel goed bij jou past. Er zitten de technische kanten in van anonimiteit, cryptografie, maar ook de juridische kanten. En elke keer als ik dan iets zie in de publiciteit, denk ik misschien, zit Luc daarachter. Laatst de gemeente Eindhoven, die werd berispt op nalatigheden qua privacy met hun basisregistratie persoonsgegevens. En dat is misschien iets van Luc. Nou, dat denk ik dat ik in de toekomst zal blijven doen. En ik hoop dat jij daar ook je ei kwijt kan en veel plezier hebt straks met dat werk bij de autoriteit.
So the department also has a very active study association, and we're quite happy with all the activities they organize for our students. And on behalf of GWIS, the study association, the chair will now give a speech.
Dear students, or actually ex-students, as you've now all graduated, dear family members, friends, or other attendees. As already introduced, my name is Witske de Bond. I'm the current chair of GWIS, the study association, both for mathematics and computer science, but also embedded systems and IST is part of that. And as GWIS, we organize all kinds of activities ranging from, for example, mathematics competitions to parties, but also from career lunch lectures to fun outdoor weekends. Also, for example, the Running de Batavieren days, as one of you have also helped with organizing once. But today, it's about you. Today is a special day. It's your official graduation, and here you receive your master's degree. And this master's degree represents all the knowledge and lessons you've learned here within the computer science department, but also as your journey as a student. But also on this day, if we go back in time 107 years ago, Albert Einstein published his theory of relativity, which was which describes gravity in the modern physics, which really was the elegant successor of Newton's law of gravity, which I think everyone remembers. And in a similar fashion, I hope that you in your future might be able to do something new and have a valuable contribution to science or to society or the world. And at this moment, you've received your degree, you're really at a new chapter of your life. Maybe you will continue with a PhD here at university, maybe you'll start a job at a company, maybe you really don't know what to do yet, but this is a time to start achieving many more goals. And I also wish you that you can do that. And receiving this degree is only there for a small population, and I think you can be really proud of yourself. It requires you probably a lot of motivation and energy, especially also in times of a pandemic. So you can be very proud of yourselves, but I also hope that your family and friends are really proud of you. And I am also very proud of you on behalf of GWIS. And as you're now all alumni, you're also invited to join ADA, the recently founded alumni association, to stay in contact with fellow alumni and still feel connected with the mathematics and computer science department. So, ladies and gentlemen, the last thing for me to say once again is to congratulate you again with this wonderful achievement. And I hope that is maybe a stimulus for the rest of your life, that you can achieve anything you want to achieve.
Dear Masters of Science, Also on behalf of the Department of Mathematics and Computer Science and Electrical Engineering, I want to join all the speakers and congratulate you on your degree. And I wish you every success and fortune in your future careers. I should also add that now that you have an academic degree, that also comes with responsibilities, and in particular, you should take care that you follow the code of conduct of for scientific research, and also the Eindhoven Code derived on that. We're almost there, but we will now take a few photos here with all the candidates and also the committee. So as for the audience, you can already go outside and have some drinks.
I should take the picture outside.
Okay.
So I want to ask all the parents and family to stay here.
Okay, we do it the other way around, so let me not read what's here. So we go outside for the pictures, you wait, and then when we're done, we will call you outside.
And I would take 2 pictures again, you two and the candidate, because someone has closed his eyes.
Okay.
You can do that after the picture there, right?
Yeah.
That's maybe,
Yeah.
yes.
Yeah.